You ever wonder how your phone, your laptop, and some server halfway across the world can all have a perfect conversation when, sometimes you and a friend can't even agree on what to have for dinner? Well, it all comes down to a set of invisible rules. And today, we're going to pull back the curtain on what really makes our digital world tick.
All right, let's start with something super relatable. We've all been there, right? You're in a conversation, you're trying to get your point across, and it just falls apart. You're talking, they're talking, but nothing's actually connecting.
You know how it goes. Maybe one person is just talking a mile a minute, or they're using all this jargon you don't understand. Or, and this is the worst, maybe one person just won't stop talking. They never leave a moment for you to reply. Whatever the case, the unspoken rules of conversation get broken, and the whole thing just grinds to a halt. So this brings up a really fascinating question. I mean, if we humans, with all our social cues and everything, struggle with this, how in the world do our devices manage to have billions of flawless conversations every single second? What's stopping the entire internet from just collapsing into a giant mess of digital miscommunication? It's kind of mind-boggling when you think about it.
Well, the answer is all about preventing that chaos before it can even start. See, before we can even get to the rules, we first have to appreciate just how easily our digital world could fall apart. We need to understand why a clear rulebook isn't just, a nice to have, it's absolutely essential. And when you break it down, a digital conversation isn't all that different from a human one. I mean, they both have the same basic parts, right? You've got a sender and a receiver. You've got the message itself, and you need something that carry it. For us, that's the air carrying our voices. For our devices, it's data zipping through cables or Wi-Fi signals.
Okay, so if we're going to write a rule book for these conversations, we first have to know what kind of conversations we're dealing with. And it turns out pretty much all digital communication boils down to just three fundamental patterns. Think of them as the basic types of digital chats. This whole idea is called data flow, and really it's all about one simple thing. Which way is the conversation going? Is it a one-way street, like a lecture, a back-and-forth debate where you have to take turns, or more of a free-for-all discussion? Okay, first up, the simplest type. It's called Simplex. Just think of it like a monologue. The data only ever goes in one direction, period. Your keyboard is a perfect example. It sends commands to your computer, but your computer never sends anything back to the keyboard. It's a classic one-way street. Next, we've got something called half-duplex. Now here, both devices can send and receive, but, and this is the really important part, they can't do it at the same time. The best way to think about this is a walkie-talkie. You press the button to talk, you say your piece, then you let go to listen. Over. And last but not least, we have the one we use for almost everything these days, full-duplex. This is a true two-way street. Both devices can send and receive data at the exact same time. It's just like a normal phone call. You don't have to wait for the other person to finish their sentence before you can jump in. So why does any of this matter? Well, because every single digital interaction, I'm talking everything from a simple mouse click to streaming a 4K movie, is built on one of these three patterns. You gotta understand the flow before you can even begin to control the traffic. All right, so we've figured out the direction of the traffic. That's a great start. But what about managing everything that's happening inside that traffic? To bring some real order to all that potential chaos, we're gonna need that rule book we talked about. And that rulebook has a name. It's called a protocol. Simply put, it's a set of rules that devices agree to follow before they even start talking. It's basically the digital version of grammar, syntax, and good manners all rolled into one. And let me tell you, without it, you'd have pure digital anarchy. And what's so cool is that protocols are designed to solve the exact same problems we talked about with that failed human conversation. They manage speed, they make sure everyone is speaking the same language, they control the timing of the whole back and forth, and they even have ways to make sure the message was actually received and understood correctly. Think of a protocol as a conductor for a digital orchestra. It's the ultimate moderator. It defines exactly what is communicated, how it's communicated, and when it's communicated. It's the thing that makes sure all the different parts are playing together in perfect harmony, instead of just making a bunch of noise. So what's actually in this rulebook? What are these rules? Let's pop the hood and take a look at the key elements that protocols use to manage a conversation from beginning to end. Basically, it boils down to a few key things.
The protocol has to define how the message is encoded and formatted, what its size should be, how the timing is managed, and of course, the delivery options. Who is it going to? Okay, first things first, a message has to get ready for its trip. That starts with encoding and formatting. Encoding turns your data into signals that can actually travel, like pulses of light or radio waves. And formatting is like putting that data into an envelope with the right sender and receiver info on it. Then there's sizing. You can't just send a giant file all at once. Sizing breaks big messages down into smaller, more manageable pieces called packets. It's kind of like breaking a long story into shorter sentences.
Next up is timing, and this is absolutely critical. You've got something called flow control. This is basically a traffic cop that stops a really fast sender from totally overwhelming a slower receiver with a flood of data. Then you have response timing. This decides how long a device should wait for an I got it message before it just assumes the packet got lost and sends it again. Super important for reliability.
Okay, so our message is formatted, it's the right size, and the timing is all sorted out. The last piece of the puzzle is delivery. The protocol has to know who gets the message. Is this a one-on-one chat, a group text, or a blast to everyone? And here, there are basically 3 ways to go. You've got Unicast, which is a one-to-one conversation, just like a DM. Then there's multicast, which is one-to-some. Think of a video stream that only goes out to people who subscribed. And finally, you have broadcast. That's one-to-all, a message that goes out to every single device on the network, like a public announcement. So here's the big takeaway. Every single time you load a web page, send a text message, or stream a show, this entire complex, invisible system of rules is working behind the scenes. All of it, from the data flow to the delivery options, is working in perfect harmony. It's the silent hero that's constantly turning potential chaos into the orderly, reliable communication we all depend on. And that really brings us to a final thought. We've just peeled back the curtain on the hidden rulebook of the internet. And it kind of makes you wonder, doesn't it? What other invisible rules and systems are out there, quietly making our modern world possible? It's something to think about. Thanks so much for diving into this with me.